Find the angle between the following curves. X squared plus y squared equals 5 and y squared equals 4x plus 8. So now, what we need to do is to first find the point of intersection. And we can find the point of intersection by solving these two curves, the equation of these two curves simultaneously. So now, let's say that x squared plus y squared, so that is equal to 5. Let's label that as equation 1. And then y squared equals 4x plus 8. Let's label that as equation 2. So now, since there is y squared here, we can substitute equation 2 into equation 1. So it becomes x squared plus 4x plus 8 is equal to 5. So let's bring 5 to the left hand side. It will become x squared plus 4x plus 8 minus 5 equals 0. So x squared plus 4x, then 8 minus 5 is 3, so plus 3 is equal to 0. So this is a quadratic equation. We need two numbers that when we multiply you get 3, but when you add you get 4. So those numbers are 1 and 3. So now x plus 1 and then x plus 3 is equal to 0. So the values of x are x equals minus 3 or x equals minus 1 or x equals minus 3. Now, so since we have the values of x, then we need to put it back into equation 2 to find the values of y. But we know that y squared is equal to 4x plus 8. So it implies that y is equal to square root of, so now using x equals 1, 4 times minus 1 plus 8. And that is equal to square root of 4 times minus 1 is minus 4. Minus 4 plus 8 is 4. Therefore, square root of 4 is 2. So the point x equals minus 1 and y equals 2 is one of the intersection points. Now, let's find as x is equal to minus 3, what is the value of y? Y is equal to the square root of 4 times minus 3 plus 8. So y is equal to square root of 4 times minus 3 is minus 12 plus 8. We'll get minus 4. And then square root of minus 4 will give us an imaginary number. But we know that the angle we are supposed to get is supposed to be a real angle and not imaginary angles. And therefore, the solution of x equals minus 3, we will throw it away. So this means that x cannot be equal to minus 3. X is only equal to minus 1 as y is equal to 2. So the next thing we need to do is to take equation 1, which is x squared plus y squared equals 5. Then we need to differentiate this equation. If you differentiate x squared, you will get 2x. And if you differentiate y squared, you get 2y dy dx. And then this is equal to, if you differentiate 5, you get 0. So if you make dy dx the subject, then dy dx is equal to minus x over y. Now, the reason why we are differentiating dy dx is such that we can find the tangent to the curve. So now, let's find dy dx evaluated at that point of intersection, which is minus 1 and 2. So dy dx evaluated at minus 1 and then 2 is equal to, wherever you see x here, you put minus 1. And wherever you see y, you put 2. So it becomes minus 1 divided by 2. And that is equal to 1 over 2. Now, let's take this curve, which is y squared equals 4x plus 8, and find the tangent there. So if you differentiate y squared, you get 2y dy dx. And then this is equal to, if you differentiate 4x, is 4. And if you differentiate 8, is 0. dy dx is equal to 2 divided by y. Now we need to find dy dx evaluated at that point of intersection, which is minus 1 and 2. So that is equal to 2 divided by 2. And 2 divided by 2 is 1. So you can see that now we have two tangents. So let's say this is tangent 1. So let's say this is tan theta 1, and that is equal to 1 over 2. And then let's say this is tan theta 2, and that is equal to 1. Now from trigonometry, we know that tan theta is equal to tan theta 2 minus tan theta 1 divided by 1 plus tan theta 2 tan theta 1. But we've already established that tan theta 2 is equal to 1, and then tan theta 1 is equal to 1 over 2. So it implies that tan theta is equal to tan theta 2, which is 1, minus tan theta 1, 1 over 2, divided by 1 plus tan theta 2, which is 1, times tan theta 1, 1 over 2. So this is equal to 1 minus 1 over 2 is 1 over 2, divided by 1 plus 1 times 1 over 2 is 1 over 2. 1 over 2 plus 1 is 3 over 2. So this is equal to 1 over 2 divided by 3 over 2 is 1 over 3. And therefore, this implies that tan theta is equal to 1 over 3. So theta is equal to the tan inverse of 1 over 3. And tan inverse of 1 over 3 is equal to 18.4 degrees. So the angle between those two curves is 18.4 degrees. Now let's prove this identity, just for clarity's sake. Let's assume that we are having this is our xy plane, and then we have two lines that intersect each other at this point, such that this one makes an angle theta 1 with the horizontal, and then this one makes an angle theta 2 with the horizontal, and then the angle between them here is theta. You see that these are opposite angles, so it implies that this side too is theta. So therefore, from the rules of trigonometry, we see that theta 2 is equal to theta 1 plus theta. And if you make theta the subject, see that theta is equal to theta 2 minus theta 1. So therefore, tan theta is equal to tan into bracket theta 2 minus theta 1. And using the tan identities, this is the same as tan theta 2 minus tan theta 1 divided by 1 plus tan theta 2 tan theta 1. So this is where that trig identity is coming from. Now in some other books, instead of seeing tan theta 2 and tan theta 1, they will say m1 m2 minus m1 divided by 1 plus m2 m1. But we know that m is the gradient and tangent is the gradient, so it's just a replacement of the tangent with the gradient, which is still the same thing.